All right, class. Alrighty, so this one's going to be a good one. This is 7.4. Now, I want to let you know, this is the last section of this unit. Okay, last section of this unit. So that means that on Friday, we're going to finish the notes. On Monday, it's going to be an assignment to finish and do your review. Wednesday, I'm going to go over the review that you are doing, like good students, for your Monday I-Day. And then we're going to be taking the test Friday next week. Okay? So, I'm hoping everyone's going to do pretty well on this. Now, right here we have vectors, operations, and dot product. So, if you wrote down the homework, we can't do the first couple of them, because I believe the first couple problems says that it goes along with the example 3, but it's example 3 and 5. It didn't actually say that, but it's, so we really can't do the first part until Friday. So I think it's like number 33 or 13 or something like that. What does it start with?
I don't even know.
19?
Yeah, 19 through 27.
Yeah, so we're going to hold off on that, so you can start at 33 for today now. All right, so vectors, operations. So scalar, magnitude of a quantity can be represented by a real number. Vector in the plane is a directed line segment. So it's basically a ray. So if you've had physics, great. You probably should know a lot of these things. If you don't sweat it. It's actually pretty easy here. So vector OP would be ray OP, O initial point, P is the terminal point. Now, what does terminal mean? End. That's where it ends. I can't believe you said. Of my last class, they're like, oh man, and I was like, oh, well, how about terminal cancer? And they finally paid attention. Like, oh, terminal cancer, you dead. So that means, okay, that's when the line dies. They're like, why'd you have to use terminal cancer? I'm like, what other terminal do you know? I know, but there was no airport commentary in that class. They're like, oh yeah. 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 No, it was this class. Yeah. Yeah. Anyway, so endpoint. So terminal point's the endpoint. Okay, magnitude, length of a vector expressed as those bars, OP, and it means that it starts at O, goes to P, and that's magnitude, so length of the vector. Two vectors are equal if and only if they have the same magnitude and same direction. In this one right here, we have OP going up and to the right, where OP is going down and to the left, right? Are they the same? No. Vectors OP and PO have the same magnitude but opposite directions there. So
PO and OP.
A is equal to B, right? Same length, same direction. Because they're parallel, right?
Right.
C equal to D. Same length and parallel, right?
Mm-hmm.
A is not equal to E. They look like they're the same length, but not parallel, not the same direction, right? A is not equal to F, not the same length, but they look like they're going the same direction. All right, sum of two vectors. You know what? I'm going to skip this one because I'm going to keep this as part of the example we're going to work on later on Friday, because it was confusing to most people here. Now, scalar. So, scalar product is real number k, and a vector u is the vector ku with magnitude k. So now, think of it like this. A scalar means that I'm going to go the distance from here to Lux. Okay? That's going to be my vector. Okay? It has a distance, it has a direction, so that's my vector. But a scalar would mean I'm going to go 5 times the distance from here to Lux. So what does that mean? I'm going from here to Lux, and that same distance, I'm doing it 4 more times, right? So that's what a scalar is. It gives me the same direction, same length, but now this one's going to be 5 times that amount. And that's what scalar does. So if it's a whole number, it's going to make it bigger. If it is a fraction, like 1/2, 1/3, it's going to make it smaller. So right here, 3/2, okay, it's always going to be a multiplication, even though that you will see some that will be like this. So it's 1/2 multiplied by u. Yes?
Is it always 5? No, right?
No. We're
No, because you said except by 5, so I was like,
He was just giving an example.
yeah, just the
I was
example.
just clarifying.
I'm sorry. Yeah.
Yeah.
Took me a second. So yeah, so here to Lux. Actually, I've been teaching here like 9, 10 years now. I don't think I've ever been to Lux. I really straight up did not know where it was.
It's mid.
It's mid.
It's just hippie, like just
Okay,
like,
alright.
whatever.
It's just like this, like downtown thing, like accepting.
It's moo bougie,
Yeah, it's like almost every downtown thing, like fake bougie for like hipsters and like.
and so it's overly expensive for bougie people.
Yeah.
Okay.
Yeah.
All right. So a vector with its initial position at the origin is called a position vector. A position vector u is with its endpoint at the point AB is written as. Now, this is vector notation now. It is not parentheses. It is vector. Okay? So, that is key. I know you guys are all making sure you highlight that because that one's going to change everything. So, there is a point AB using parentheses, but vector means I'm starting at the origin and I'm going to this point out here. So, A is going to be my x value. B is going to be my y value. So the horizontal vertical component of vector u, position, angle between the x and the positive vector, directional angle. So in basic English, you're going to get an angle that goes along with that vector. Magnitude, length of a vector u in my vector of AB is given by this. This is how we solve it. Yes? Okay, now this direction is going to be different because some people that don't like to take the notes for the I-Day forgot to write down any of the problems that I change because I change formulas. I do. I don't know if you guys realize that. I try to make them easier. So when they're in the notes and you don't take them and you say, hey, I don't know how to do this, and I'm like, hey, let's look at the notes. Oh, you didn't do it? Okay, you're bad. Anyway, don't forget like, share, and subscribe because I'm at like 397. What should I do for 400?
Oh yeah.
Okay, anyway, so directional angle theta satisfies tan theta equals b over a. Now, if you're looking for the angle, you do the... Thank you. That was a yawn, right? Okay. So we're going to do the inverse. So I'm going to change this formula. So I'm going to say, because we're going to look for the angle, it's theta is equal to inverse tangent of b over a. Jess, what mode do you think this one should be in? Degrees. These are all degrees. All right, so what? Yeah, seriously. It's only 6, 7 letters, 7 characters to write down. That's it. Some people. Can I go now? Forget you. All right, magnitude. We're going to do the magnitude of this. So to get the magnitude of this, what's my vector called? What's the name of this vector?
3 negative 2.
Try again.
You.
Thank you. You.
Oh, come on.
Come on, soldier boy. You.
No.
Oh, come on. I tried.
That's like 2 generations back.
Oh.
Like,
You're supposed to do a dance with the fuck. Come on now.
Exactly.
TikTok.
that's Superman. That.
Oh.
Superman.
just some math. What does that do?
Now, leave it as a radical. If it's not a perfect square, leave it as a radical. And I know y'all are doing your math right now, right? Oh, I know, right? What is 3 squared?
9.
What's negative 2 squared? Add those together.
Subtract them. Oh, add them, because 9 plus 4, 13.
Thank you. So my magnitude is radical 13.
Wait, but isn't it would be positive, right?
I'm sorry, it's supposed to be a plus. My thing's not right. My thing didn't write that down.
I was about to say.
I'm sorry, apologize. It is supposed to be a plus.
Why you even?
All right, so my magnitude is rad 13, right? Say yes.
Yes.
Okay, good. Directional angle. Now I want to find theta. Ooh, how would I find theta? Inverse tangent. My B is?
B is y, so
Y
it's
over X.
negative 2 over 3. That was my redemption right there.
Yes, sir. I forgot my X and Y when I was like,
The alphabetical order.
I don't know, no, but like,
What?
I just forgot it.
So when we do the magnitude, like
I'm not
what
getting-
the 3 and the 2 is, are we always gonna put an X on it?
Yeah.
Or maybe let's put it.
I'm not
Yeah.
talking about that.
For the figure out the theta, is it always inverse tangent?
Yeah, it's always inverse tangent. That's why we wrote it down on the formula page.
Oh, because of the thing that you showed us before.
That was like you fucked up before. You were here.
That one. To find the thing right here.
Yeah, I've been
And
here
then
longer,
just plug
but
that in. and
still.
then-
So you from here. You from here. You from here. And that just, you know what
So
that
this is
sound
the
like.
Y and this is-
Exactly, but I'm here.
Yeah.
I'm not from here because I've been here.
We said inverse tangent.
Negative 2 over 3.
Wanna be.
So what's my answer?
Negative 33.7.
Very good, negative 33.7.
You was born here.
And don't forget, negative angles go backwards. So is that correct?
Yeah.
Yeah, that's fine. Is that pretty easy there?
Just put the numbers in the formula, put the formula in the calculator, write down the answer.
Difficult.
Is that it?
Yeah, so now, do you want me to show you even easier?
Oh. There you go.
Wait, it's negative?
All right, next slide. Now, see this right here? Is this on your notes?
No.
Oh! So what do you think you should do? Yeah, do that.
Wait, all of the red stuff?
Watch this. Are we using the TI Inspire?
Yes.
Okay, so let's see. So for this, I'm gonna type unit V and 3 negative 2. So I'm gonna type it out. Type it out. Watch. I'm writing it like write it right now. U N I T V. You notice it changed from squiggly to like straight up and down, right?
Italic.
Ooh, I know, right? Times New Roman. Anyway, you ready? Parentheses, but inside the parentheses, because we don't have the vector notation for this, you hit Control, parentheses again, and that opens up my vector for this. And we had, what was it? 3, comma,
Negative 2.
negative 2.
And then close it the same way.
Hold on, wait a minute.
Where's the comma?
The comma's down below the pi.
Yeah, below pi. And then close it the same way, right?
You at this point right here, because you're already closed with your bracket, you could just arrow over and close the parentheses. Or if you don't have anything else you're gonna do, you could actually hit enter here.
Wait, mister, my brackets are different.
Yeah, mine are like squiggly.
Cause y'all put the wrong.
Okay, so see the open parentheses?
Oh, is the B supposed to be
The
capital?
first,
Y'all
press the
messed it
first
up.
one, not the second.
Yeah, it's the bracket. The other
Yeah,
one.
the first one, the first.
Yes, it's the first one. So you control open parentheses. That's the left one, not the right one.
Oh, I see it.
Checking if it's charging this time. And it's not.
I think it's just your phone.
It's not.
Your phone sucks. Do you
I
have a regular
better
cable?
phone than you.
Yeah, you have a cable? Is that an iPhone?
Yeah.
Anyone got an iPhone cable? Yeah, she's already dead, so.
Wait.
Look at that. Look. See?
It been doing that.
It been doing that?
Yeah.
Wait, mister, can you
What's
put it
what's
in
in
the red?
There we go.
between that?
How did you
Space?
do the parentheses?
It'll get you like upwards of 50 by the end of class.
What? What am I doing
I
wrong?
heard
It-
that.
Okay. So here it is here. So what's the question again? I heard like 3 people saying things, but someone's up here at my desk complaining about her phone not charging.
How do you get the parentheses, both of them?
Parentheses?
And the
Okay, I'll do it again. Let's type it out. U-N-I-T-V. Parentheses is right here. See this where my mouse is? It's the left parentheses. So open,
I see. And then control.
then control, same one, it's going to do your bracket.
Oh, okay.
There we go.
Oh.
Then I'm gonna put 3, comma, -2, and just hit enter.
Why is it not letting me?
Then why'd you block the picture?
Oh, it says that it's a test restriction. I'm in a test.
You're in. I'm sorry.
I know, right? I got stuck in some tests. I don't know.
I don't know, some special person, I'm just gonna say special. They don't know how to use a calculator, so they somehow turn on test. I don't even know how to turn on the test mode on the calculator. I really don't. I just know how to turn it off from up here.
I got trolled.
Are you out of it yet? Okay, good. Anyway, here we go. So from here, the next part of this is you take this answer, hit enter. So now that it's set up right here, you're going to do this. Book, triangle. No. I don't want DMS. We've been using DMS, but we're going to use something else today. So, book, remember book with the black triangle that we had always used DMS, right? But we're not doing DMS, we're doing polar. P
Like magnets?
O L A R. So if you notice it changed from italics to regular.
Mm-hmm. Oh.
Yeah.
Wait, what?
And that gives me my angles too.
How did you copy it down?
Oh, that's
Arrow
number
up.
one.
Yeah.
Type in polar.
And it's,
After the triangle, you
Enter?
yeah,
Where G O.
Oh.
Yeah.
Thank you.
there we go. So that can get us our angle too, but it's more complicated. But I still want to show you guys how to do it. It is more complicated, but I prefer that you just do it by hand. There's another way of doing it later on that we will do next unit. So,
The last unit?
yeah.
Can you go back to the red thing?
All right.
The evil block.
Wait, so can you like leave that
Everybody
so
know
you
that
can
that's
type
when you
it
go
down?
to jail.
Okay, so I will come back to this I will come back to this after example 2 because I'm going to give you time to work on the homework. Oh, okay.
Everybody knows about that.
But it's easier to do it by hand. That's what I was trying to say.
Oh, we could do this by hand.
Watch her go back.
Oh, by hand?
All right, so
Whoa, by hand.
now listen up, please.
I'll send it to
Watch out.
Watch it go
Hey,
back.
someone airdrop it.
Okay, I got you. Put your drop on.
And
Never mind.
he's
I
so
sent
mad.
you.
I told you I'll put it back in a minute.
I think a waffle cheer him up.
Now, horizontal and vertical components. This is going to be probably one of the bigger parts because this goes into next unit. So, for this right here, it says horizontal vertical components of vector u having magnitude u, directional angle theta are given by A, which is my x direction, is equal to u, which is my magnitude times cosine theta. The A is my magnitude times sine theta. So when we put that together, we can write it out like this format here. And I'll show you how to fix that, how to take care of that. Now, vector W has a magnitude of 25. So we're going to find the A value, which is also referred to as your x direction, right? So my A, to solve for A, I would do my magnitude, which is
Equals,
25
So what, yeah, 25
times
cosine
cosine
41.7.
41.7. There we go.
And then A.
Yeah, and that's going to be it for that one. That's going to be that value. That's going to be your A direction. Huh?
How did you get cosine?
Did you look at the previous page? I figured. So see it right there where it says, yeah. Yes. Thank you. Yes.
How do you know that's A? Like, how do you know if it's A or U?
No, I know that.
Well, yeah, you gotta find both. Though.
Oh, but
Yeah.
I know,
Because
but
you
like,
have to.
How did you get 25 X?
Oh,
that's the.
it gave you the
So
magnitude.
that was given.
Oh,
So I don't know if you can see that from here.
okay.
I know you have your glasses, but I don't know if it.
I can see it.
Ah.
Shorty, not everything.
Like 1 month ago, you were like right here, and
I know.
okay, so magnitude is also right there too, and my theta is also right there. So you can get it from there, or you can get it from the language in there.
So is the A always going to be the given?
No,
No,
no. A is your x direction. So we're gonna do that, and then to get the B, which is my y direction, I would have
B. Wait, no.
25
Sine
sine.
41.7.
So it's just the same numbers, just.
Yeah, because cosine is your x value, right? Cosine on my unit circle is my x value. That's the left and right. Sine is the y value, which is the up and down. And that's why we have those directions. So go ahead, plug those in. What are we going to get for A?
A is 18.7.
18.7. And B is going to be,
16.6.
is one of those negative?
No.
No, they're not. So what that means is, over here, this location is 18.7 by 16.6. That's what that means.
So given you have to find the magnitude and the angle. But if
So my x direction would be basically me going forward, and then my y direction would be me going left. So in my directional sense, I am walking straight west, and I am going to central. Okay, I'm going directly to central, and when I get to central, what am I going to do?
Go up.
I'm going to go up. I'm going to go left. In this case, right? We're going to Lux. Isn't it left?
I don't know.
Yeah. From here?
Yeah.
Let's
Yeah,
just
okay.
make it left.
Okay, yeah, let's make it left. So I go straight over to the central, and then go left. So that's my directions. Yes.
So then that vector, wait, we're finding the magnitude.
We're
Wait,
finding
the
like
magnitude is
the
given.
right.
So, wait, it's mentioned back in like the previous notes. What I mean.
We're finding the horizontal and vertical components.
Which is my A and B.
Yeah.
So which one is wait, horizontal is A, and then vertical. Should have just said that. Is it always gonna be vertical?
Oh, come on, Bacho.
He's so
What is
mad.
the point that we're like, because it's A, B, C, wait, A, B, C, A. So I guess we're looking at big A, that where that angle is.
Actually, hold on. Watch this. I will redraw this, and I will show what everything means. So, you ready? Going from here to here is my theta, right? The distance from here to here was 25, so that's the length of that. That's the distance. So that's the magnitude right there, okay? That's the magnitude of that. And the location where that magnitude ends is going to be right here as A, comma, B.
Yeah, I was asking for the name for that.
It's the destination.
Yeah, okay, so now, if you die, it is the terminal point. There we go, right? Now, does that make sense? I'm hoping I'm answering everyone's questions on this, because it is pretty easy as long as you are following along.
It's like finding another triangle. It's just in a different way.
Yeah. All right, how about this? I'm going to pause right here. You're going to do some of the homework starting on number 33, and then we will go back and do example 3.
Can you put the homework up?
All right, okay, for this next example, we're going to take a look at example 3, and then on Friday, we're going to finish up with these notes. Okay, so you're going to be able to do some of this, not all of it, today. But you should be able to finish up all, 33 through 47 before you walk out of class here today. So, write each vector in the figure in form A, comma, B. So, vector notation. So, we have 3 different ones on here. So, I'm going to start with U. To get U, I'm going to start with, what is the magnitude on U? 5. What's my direction on U?
60. Wait. Yeah.
It is 60, right? So now we go 5 cosine of 60, comma, 5 sine of 60. So please calculate that.
Wait, so you have to do the unit VP?
No, you don't have to do all that. Just plug in each piece individually. 5 cosine 60.
So you get 2.5.
You get 2.5 for that.
And then you get
Hold on.
4.3. Yeah, because if it's 60 degrees and it's sine, and there's only 5, it's gonna be bigger, right?
Wait, are we supposed to have the brackets and stuff?
No, we're adding this. What you're doing is each piece individually. Kind of like we did on example 2. So you're doing this, so we got 2.5 here, and do the second piece right here, and you come up with?
4.3.
Yeah. You guys agree?
Yeah.
All right.
And then we do that unit thing or no?
So hopefully you find this pretty easy here though, right? We don't have to do anything else. That's it.
Okay.
Write each vector in this form. Now let's do the next vector. Let's do V.
Oh, you
No. You were just too quick. Everyone is still trying to plug this in. All right, so V. To get V, now, what is the magnitude on V? 2. What's my angle?
280.
So it's going to be 2 and times cosine of,
280.
try again,
Is it 280?
it is 180.
Oh,
Look at where V is at. It's right here. This is 180 here.
okay.
Oh.
Okay.
Well,
So,
Makes sense.
you
280.
Cosine 180.
You doing V right now?
Yes, I am. Comma. My magnitude again is 2. Sine. And so my vector notation for this, so go ahead, plug it in the calculator.
Wait, mister, I'm confused on how do
Do
you
you
know
know?
which, like the 180
Do it yourself.
Dang.
goes with the 2?
Huh?
How do you know the 180 goes with the 2 and the 5 goes with the 60?
Right here. See this 2 right here attached to that? Like right here next to it?
Yeah.
That's why. So there is that. And if you notice, this
Right.
arrow is pointing towards that.
But what about the 5 and the 60?
Look at where the 5 is.
Yeah, I see that.
Yeah, the 5 is there, and then the 60 arrows up to that.
So does that mean the 0's with the 6?
The zeros with
Or 60? Wait.
no. What's that? That's not a 0. That's the origin right there.
Okay.
That's the origin, because when we're talking about these, everyone is starting from the origin.
Oh,
Oh,
so
it's a
280.
280 goes with my W. All right, so let's try it again. So I'm going to set it up. So for W, my vector is, so what's my magnitude?
6
So it's going to be 6 times
cosine
of,
280.
yep, comma,
6 sine 280.
yep. So my vector, so
1.04 and then negative 5.9.
and what'd you say?
Negative 5.9.
So I'm hoping that everyone actually finds this pretty simple. It's not meant to be too complicated. There's a lot of formulas that we have just for this. So everything is just plugging in, put it in the calculator. Yes, you could use the regular TI-84 calculator that you installed on your computers. So I'm going to give you guys the rest of this time to finish up this assignment, but you cannot finish, 19 through 27. You can't do 19 through 27. Those ones right there are going to go along with Friday's notes. Okay? So make sure you like, share, and subscribe. Hit that notification button. And use promo code, I think it's still DJ Versailles, Basil. 10% off merch store.